in a not so far away land, there was this team that wanted to deliver so fast into production that all their issues could just fly through the Jira flow in no time at all. This team was a development team, of course. This fairy tale is not about princesses and dragons or witches, but it is about engineers. And two of those engineers are here today. My name is Tina. I have been on this project for about almost 5 years now. And I started out as a tester. And of course, through the years, I have evolved. And now I am the test manager.
I'm Hoem. I've been part of this team for about 5 years as well. First as a developer and now as a tech lead for one of the systems. So this fairy tale is about a team at the Norwegian Public Roads Administration, or Statens vegvesen in Norwegian. It's a case-working system that helps you get your driving license. It's used across all the traffic stations in Norway. It's been in production since 2013, and it's undergone a lot of changes since.
Yes. So our story actually starts in 2019, because then we had worked the same way for a couple of years. It started out with us together with the customer deciding which issues or features were to be delivered into the next delivery. Then we had 4 weeks of development. I wrote the test cases to all the new features, while Oda, she developed. Sometimes she developed several issues. Sometimes it was just one big issue. Then we went on to the system testing, where I, of course, then tested everything Oda and all the other developers had created. That was for about 1.5 weeks. Then we actually got the testers from Statens vegvesen, our customer. These were actually case workers working on the different traffic stations around the country. We got them to come in and do the same testing as we had done, because they have the domain knowledge. We don't have that so much as they do. So we got them to come in and test. And then they had their own acceptance testing, where they tested with their own tests and their own way of testing. And one of the reasons why we did it like this was because earlier they had found so many showstoppers late in the acceptance testing period, and then they wouldn't get to reach their fixed dates, because we had fixed dates for all our deliveries for the years, so we couldn't miss those fixed dates. And one of the reasons for this was the fact that it was operations who actually deployed. They deployed both into the acceptance testing environment and into the production environment. And when we wanted something in the acceptance test environment or production environment, we had to deliver. We had 2 times a week that we could deliver our package. And then it would come out after about 3 days. So it took a lot of time to get things into the different environments, which is also why we had to take our testers and use them double, so that we didn't miss any important things early on. Because if they found a bug late in the acceptance testing period, we wouldn't reach our delivery dates. Another thing that was a problem for us was that creating these packages were pretty time-consuming. We had 4 weeks of development, and often this development continued on into the system testing. We barely actually made it through with all the bug fixes and such when the system testing with their testers were actually done. So the person or environmental guru who actually created this package could use several days, maybe sometimes even a week, to actually create this package. So everything just took a lot of time. But we had heard about something new that was coming. Other teams in Supplier, which is of course where we work, talked about delivering into production daily, sometimes even more than once a day. And all of us on our team were like, oh my God, is this even possible? Is this something we maybe could do? And yes, it was. So why did we want this?
As Tina mentioned, we had fixed days for deployment to production. We did it 8 times a year, so the releases were huge. We had a lot of test environments to manage, developing environment, system test, and acceptance test. We had a lot of manual test, about 6 weeks of testing in system test and acceptance test. And we had several handovers, both inside the team and externally. So I, as a developer, would get a list of demands or specifications from the system owner. I would implement them, then send it over to test and start on the next release or sometimes bug fixes. And test would test, and then 1 or 2 persons would make the release package and hand it over to operations, who would deploy it to acceptance test, where the caseworkers did their testing, and then again operations would deploy to production. So I could get a bug from production about a month later and had to fix it and remember what I did. So what we wanted to do was to be able to deploy by need and not having to wait for these fixed dates. We wanted fewer test environments to manage, more automated tests so that our testers can use their knowledge to actually make good test cases and find the edge cases and not having to test the same over and over again. We wanted to deploy by ourselves, the team being able to deploy themselves, not having to give it over to operations. And we also wanted more cross-functional teams so that we are one team working towards one goal instead of different smaller teams working on different parts of the production line. So we wanted to work more together as one team.
Yeah, and before we could start this journey, we had some assumed challenges that we thought would arise. One of these was, of course, test as a bottleneck. Like we said, we had now used 6 weeks of testing. It takes a lot of time, and we can't do this if we are to deliver more continuously. I can't use 4 weeks of just writing tests before testing. So we decided early on that we have to cut all our written tests. We don't write any tests anymore. And also we decided not to test all the bugs that didn't have any regression test needs. This is just to save us some of the time, but we still knew that there might be other things that could be problematic because our system, it went into production in 2013, and some of the code hasn't been touched since. And there wasn't that much need for, or it wasn't that much of unit tests and integration tests and so on back then. So we know that if we are to deliver continuously, we need more automated tests. Another problem was our complex issues. Like I said, Oda could maybe use the whole 4 weeks of developing just one issue. That doesn't work when we are to deliver continuously, because that also means there will be so much more to test. But we're not starting anew. We have to continue with our backlog because, like we said, it's the driver's license. So there are laws and such that are going to come either way. And we can't just toss our backlog away and then start anew. So we knew we had to do something about our backlog so that we could actually continue and do this more continuously. The last assumed challenge was that we were afraid that we would have more bugs into production. This is because things will move at a more faster pace. And of course, we are not testing as much as we did before. So we might miss something. And we are not that. And we have to use so much more time than if we are to try to be safe and not deliver bugs into production. And that's not possible. We know that this is something we just have to face and hope that won't happen too often. And as in all the fairy tales, we have some villains and some heroes. Our villains here are not people, luckily for us. Our villains are the large, big backlog with the large and complex issues. It is our routines and our processes, because we had done this for a couple of years and it worked. It wasn't the fact we didn't want to change this because it didn't work. We just wanted things to move faster. But and we didn't want to do this mini waterfall that we were doing. So we knew we had to do something about this. And also, of course, our old system. It wasn't new, so we knew we had to do something about this. The heroes of our fairy tale is, of course, the team. The team involves not only us as the supplier, but also, of course, the customer, because everyone wanted to see this work. There were often when there were law changes, and we had to say that, yeah, you can have this law change. It will come into production in 3 months. That doesn't actually work, things doesn't work like this. So everyone was on board, everyone wanted to do this. So we wished upon a star, and the star sent us a fairy godmother in the form of a new platform called Atlas that made it possible for us to actually deploy ourselves.
So Atlas is an abstraction layer on top of Red Hat OpenShift container platform, which again builds on Kubernetes and Docker. It's a separate team in Statens vegvesen that works with the Atlas platform, and it enables us to deploy ourselves. There are some requirements for the different applications to run on this platform. Among these are, it's required to use the OAuth 2 and OpenID Connect flow for authentication and authorization. We use OpenAM as the identity provider to create the ID token. It includes a few more claims than the regular token, including a list of roles that we have defined to be used within our application, so we can have role-based access within the application. The platform also helps us making an app image or a Docker image, which is the artifact and a base image that the platform provides. In the beginning, we didn't really have that many base images to choose from. It was just Java, plain Java, or Java and Tomcat. And of course, this platform made it possible for us as a team to deploy ourselves, not having to hand it over to operations. So we had a new platform, and we wanted to start using it, but we can't really do that overnight. We had to do some changes in our system as well. We already had a service-oriented architecture, but we had to make our services run on Docker. So I know this is NDC and it's a lot of .NET workers, developers here, but we are a Java project. We already used Spring MVC as a framework, so the Spring universe is quite known to us. And because we didn't have that many base images to choose from on Atlas, we started to rewrite to Spring Boot, because that enables us to bundle the application server inside a jar file and run the same file locally when you develop as on the different pods in the different environments on Atlas. At the same time, we also changed from using XML config to Java config for wiring the beans in Spring, which is a lot more easier to read and therefore also easier to maintain. As I mentioned, Atlas required us to use OAuth 2 and OpenID Connect. So we use Spring Security to handle this inside the applications. Before, we just relied on perimeter defense. That was no longer enough. We also implemented Flyway, which runs database scripts when we deploy the application instead of having to send it over to operations. We have had incidents when we weren't really sure when a database script was run, or even if anyone ever had run it. But that's no longer a problem, because it happens automatically. The second advantage with Flyway is that we get version control of the database scripts. Now that we can deploy ourselves, we are also responsible for the system's behavior and the system's health. So we have to monitor it ourselves. Atlas provides us some services for that as well. We use Prometheus to gather metrics such as CPU usage, memory usage, and then we can use Grafana to make dashboards so that it's easily readable for developers, for testers, for system owners, and operations. So now we can actually use this platform. But we have to do some changes in the way we work as well for this to go any faster than before.
Yes, so our heroes, of course, they had to meet a few challenges. And since 3 is the magic number, that is also the number of challenges we are going to talk to you guys about. The first one was, like I've mentioned before, we have this large backlog with a lot of complex issues. We knew we couldn't keep working on those, so we had to do something about them. So we started thinking, how can we divide this? And we started thinking more feature by feature. This was something we, of course, did together with the customer. But, of course, it's not just straight ahead to do this, because sometimes there are technical aspects to think about, and what I think is different functionalities is perhaps the same code. So it wasn't. We have tried and failed a lot on this, especially in the beginning. We just divided everything into smaller and smaller pieces, and the developers ended up with, okay, I've solved 2.5 issue there, 1.5 issue there, because we had just gone way out. So we knew that. So we've just been learning every time we are dividing a large issue into smaller pieces. We are just thinking, okay, how did we do this the last time? What can we learn from this, so that we don't make the same mistakes, hopefully, again. But now we have all these issues, and since we are using Jira, it's not that easy if you have like 20 issues then to just keep these connected with each other. Yeah, you can link them, but then you have to link all the 20 issues to each other. So we started using epics. Epics is not something new or anything, but we just hadn't used it before because all the features had been in one big issue. So we started using epics so that we can follow our big issue and see, okay, how much have we done, how much is left, maybe. And what we've also seen then is that sometimes we can actually take things out and create a new epic because the issues are so big. So as I said, we are still learning a lot about this, but a problem is when you have smaller issues, they don't actually have much meaning without the rest. And we can't just hold everything off. So the next thing we had to do,
we introduced the use of feature toggles or feature flags, or just switches in the code to turn on and off a new feature. This enabled us to develop continuously and deploy continuously, but made it possible to wait to actually turn on the feature. Sometimes still one feature would take a few days, maybe a week to develop, and we didn't want to stop anyone else from deploying something, but we didn't really want to do it on a feature branch for weeks either, because that's going to be a nightmare to merge. So we wanted to do it bit by bit. So then we used feature toggles instead. We are today handling them in, we make a variable in the configuration, but the problem is every time we want to change it, we have to redeploy. So we are looking at using Unleash to handle our feature toggles instead, so we don't have to redeploy every time we want to change it. That will also give us a dashboard so that the system owners and the testers also can see the values and which toggles we actually have. And they can also change the value themselves without having to do any coding. Then we can also turn on a feature in the test environments, but having it switched off in production until we are ready, until we have seen that it works. And the day we're actually going to release something, it won't be as a big bang as it was before, where we deployed a lot of code that day. That code would already be there. We will only turn it on so that it's possible to use. And of course, if it fails, it's easy to turn it off instead of having to roll back the code. It's a bit quicker. So this enables us to develop faster, but we still needed to do something about how we could actually deploy anything faster, because we had some few issues here as well.
Yes, and one of the first issues we had was the fact that during the time that we were going over to the new platform, we of course had to do a bit of features and bug fixes as well, because this went on for about a year. That means we actually neglected all our technical debt. We didn't use much time on it, and of course, because we had gone over to this new platform, we had other technical debts that we had to do something about, because we were on a new platform, things were a bit old here and there, and this took a lot of our developers. They had to work a lot on this, so we didn't get the time to do so many features and bug fixes that we actually wanted at the beginning, because we had to use our time on this. Another problem we had was the fact that in the beginning, or before we actually started trying to do this more continuously, we had only had one environmental guru who created all our release packages. And so in the beginning we thought, okay, let's do this set fixed dates. We are to deliver into production Tuesdays and Thursdays, so that our environmental guru can create the packages only twice a week. But our problem was that creating these packages took a lot longer than we thought, even though we had less code. It could take a couple of hours, or maybe even a day. So our environmental guru didn't have time to do anything else for the whole week. So we saw early on that we had to, number one, we had to go down to once a week, and we had to teach several of the developers how to create these release packages, so that we weren't reliant on just one person.
And because it took so much time making this release version manually, this person had to check out the code and bump all the dependencies to the different services that we have. We had to do it manually, had to write the version number. It's easily to make a mistake, and then build it in the right order. So if someone had a bug fix later on in a service that is used as a dependency in a lot of the other services, we had to do it again. And because it was time-consuming, sometimes while the person was checking out the code from master, someone else might have merged something else to master. So we had the risk of actually having some functionality to be part of the release that wasn't intended, or sometimes even just half the functionality, so it wouldn't work. So we had to freeze merge to master. We use Bitbucket for pull requests, and when a pull request is approved, thank you, we use a button there to merge it. So we just basically disable the button for a few hours. And this works, of course, but it's not a good solution. So we took a look at our existing build pipeline on Jenkins. It checks out the code from master, builds it, runs a few tests, and then deploys it to system test environments. I've marked the rest of the process in red because these were manual steps. So even though we had the ability to deploy ourselves to acceptance test and production, this was still a manual job. We had to do it using a command line interface talking to the Atlas platform. So the first thing we did was automating the making of the release version. We also moved it earlier in our process. So as long as all the tests are green, we make a release version. That's basically just an app image or a Docker image that can be run on Atlas. We also tag it with a unique name, a unique version number. And you can see I've made them steps deploy to acceptance test and deploy to production yellow. That's because we also made jobs on Jenkins to automatically deploy to these environments as well, but we had to trigger it manually using that unique tag we made in the release step. So now you can see that we actually deploy the exact same code to both the test environments, so we can merge these to one. And as we've mentioned, we work a lot on building new tests, technical tests that can be run as part of the pipeline. So in time, we hope to stop having the manual test phase as part of our normal process. We will, of course, always deploy to test, so we can do a manual regression test, we can do an extra check. Sometimes there are features or new fixes that we want to do extra tests on, but it doesn't have to be part of the normal process. As I mentioned, we do have a deploy job that automatically deploys to production, but today it's triggered manually. But there's nothing technically wrong. There's nothing technically stopping us from having a fully automated pipeline so that each merge to master gets out into production as long as the tests are green. But this is not where we are today. We have implemented a few more steps to our pipeline for better code quality and test quality. We use SonarQube, which is a static code analysis tool. It looks at test coverage, code smells, common security issues. And we also publish snapshots and release version to Artifactory so that it's available for the different the other systems and the other applications using our services as dependencies. And we also bumped the snapshot version on master branch after we made the release so that it's ready for the next developer to start using. And the rest of the pipeline is the same as before. But the reason we're still having these manual test phases is because we still find a lot of bugs in these phases. There's several reasons for this. As Tina mentioned, we do have a lot of older code that doesn't have unit tests or integration tests. So it's kind of a wormhole to actually do anything there. It creates a lot of regression test need. And there's something about this small fix is not necessarily a small test. I can write or change small in one service here, and it creates an avalanche of test need, even though I just changed 2 lines of code.
Yes, and because of this, the developers actually have to schedule testing so that if Oda wants to push something into the system test environment, and then maybe Ole and Petter and so on, we have to make sure that we have someone who is available to actually test their issues, so that if I find a lot of bugs on Oda's issue, which I normally don't do, luckily, then that won't stop the flow, and we don't have to roll everything back, because if we roll her things back, then we might have to roll all the others back as well. So now we have to schedule the testing. It's a bit complicated sometimes, but it mostly works. But of course, you just want to push it. And another problem is that our testing goes in waves, because in the beginning we had this once or twice a week where we actually deployed into production. Everyone, of course, wanted to deploy their stuff into production. So everyone was like, hey, now we're ready, right before we're going into production. And then right after, nobody had anything. So, which means that we as testers had to find other things to do, which we of course do. But then it was like, everyone wanted to get their things tested at the same time, which was a bit of a problem for us, since we're not that many testers. What we have done to try to fix this, one of the things we are doing is, of course, focus on the technical tests. When I say technical tests, I mean unit tests, I mean integration tests, API tests, and we also have UI tests in Selenium. So when a developer is developing something, they have to think about, should I create other types of technical tests for this? And before, they only had to test themselves that the acceptance criteria were met. But now they actually have to create technical tests in some way or another for all the acceptance criteria that our customer creates for us. Another thing we are doing is looking at testing on the branch. Because if I find a bug on the branch, it's still not in the system test environment. I don't have to create a bug. I can just tell Oda, hey, fix this. She does. And then we can push it out to system test environment later. She doesn't stop the flow for any of the other developers. And everything is just much easier for us when we can do this. Another thing we've done is trying to get our domain knowledge up and running. We've been here for 5 years. we know a lot about driver's licenses and all the different classes. Most people just know about what they need to do to drive a normal car. But there are so many other rules there, so we are working a lot on getting the domain knowledge up to everyone, especially the new ones. So what we've done is actually we have created movies where we have actually just taken everyone through the flow of getting a driver's license. And we have divided these into smaller pieces so that if Oda later has to come back and do something she hasn't done for a very long time, she can just pick out exactly that one video that she knows has the information she needs. She doesn't have to watch the whole thing because we've just divided it into different movies, which are like 1 to 8 minutes long. So if you watch the whole flow, it might take a while, but if you only need a couple of the steps, then you have it in about 5 minutes. And the last thing we've done is we have this thing we call TRAS. It actually stands for Test Counseling as a Service. In Norwegian, TRAS means defiance, which we think are pretty funny since none of the developers actually wants to talk to tests. So what we do with TRAS is that when Oda has an issue, she's going to start working on it, she is working on it, or she's finished with it. She asks if any of us testers are ready so that we can trasse. We have also created a verb of it, of course. And then we talk about what she's done. She might show us on the branch what she's done. We talk a bit, and maybe I'll ask her, oh, what about this case and this case? And then if she's not sure, then we'll just test it right there and then. I tell her what I'm going to test. Then maybe she creates technical tests for the cases that I've thought about. And when we've done this, I don't actually have to test this in the system test environment later, because we've already done this. I don't have to do the same thing twice, like we did before when we tested the same thing, not twice, but 3 times. So we are using TRAS actually just to make sure that all the developers, they are getting a lot of domain knowledge when we are talking about this and learn a lot of new things. And hopefully we can make sure that we don't get any unnecessary bugs. So these are our 3 main challenges. And I'm guessing you guys are wondering, well, you guys started at about 3 months. How is it going now? In 2019, that was the last year that we had these 8 deliveries the whole year. I'm now going, you guys don't have to watch that closely on the graph. I'm going to tell you what is necessary to know, and I'm going to show all of them in the end so that you can see them side by side. So this is 2019. As you can see, we had over 14 weeks of time that went from Oda started developing until the issue was actually into production. These images we have gotten from Jira, which has been our work tool since forever. And so these are something that we can just collect from there. And we had about 95 issues delivered this year. And then last year, in October, we started doing this more continuously. Of course, it didn't go that well in the beginning. So I'm going to show you guys February last year, which was a bit more interesting. Already here, we had gone from developing for 14 weeks to we were down to 2 weeks already here. 2 weeks and 1 day. We didn't deliver much. We had only about 13 issues. But still, we used a lot less time than we had done earlier from beginning of developing until we actually delivered things into production. And then I'm going to show you guys October because November finished yesterday, so I didn't have time to get those numbers. But October, 1 week and 2 days. And we delivered 37 issues in that month. So as you can see, our speed, we have now gone from 14 weeks to 1 week. We are delivering a lot more issues in a lot less time, of course. We don't have so big issues as we had before. So maybe those 90 issues were about 120 or something back then. And as you can see, it just goes a lot faster. It's much more fun. We see that we don't have to wait for as long before things can actually be used in production. The bugs are coming in, if there are bugs, of course. They're coming in earlier, so that Oda is barely finished actually thinking about the issue before it comes back to her. So it's been really exciting, and yeah, we are really happy about how things are actually working out. So our 3 challenges, some key takeaways.
First of all, just to reduce the issue size so that it's easier to actually develop continuously. It reduces also the cognitive load, so it's easier to actually define the scope and hopefully not make bugs when you actually know all the areas that you are developing on. It helps with tests as well. When you can develop faster, you can also deploy faster. We have reduced the amount of manual work, especially with automating this packaging, making the release package, which has helped a lot on our developing speed, deployment speed.
Yeah, and now our developers are creating more technical tests that actually test more of the domain, because they have learned a lot more of the domain. Of course, we will never know everything, because there are new rules and new laws coming in every day. But we know a lot more now, and it's much easier to create the technical test that we actually need. We also, in the beginning, talked about some of our assumed challenges. What happened to those? Well, testing as a bottleneck. We had a lot of technical debt in the beginning, so we didn't actually have test as a bottleneck. Like I said, things came in waves, so sometimes it was a lot to do, and then there was nothing to do. But lately, we don't have so much technical debt left, so lately, test has become a bottleneck. What we are trying to do then is that, since we still have our acceptance testers with us, we are actually just taking them down to test in the system test environment. We don't use as much time on the testing as we did before, because, like I said, we are not writing any tests, so we are just testing exploratory, which takes a lot less time. But of course, if you find something strange, then you'll use more time, of course. And the developers have to help. Like now, we are here, and there are just one more tester at work at home, and she can't do it all, so then all the developers have to help as well. The complex issues, we've talked a lot about those. We are dividing those into smaller features, and we are still learning a lot. Like we have one of the big epics we are working on now. It's kind of similar to one of those we had in February. So we are kind of trying to learn from that, so that we can divide it somewhat easier than we did the last time. And we are doing this, of course, together with the customer. We are not doing this by ourselves. It's actually the customer who starts this process, and then we just come in and help them, so that, because we can see things that they maybe don't, especially when it comes to the technical issues. And the last thing is more bugs into production. This hasn't actually been a problem for us. We are lucky there that we don't like to have bugs, so we try to fix them as early as possible. Sometimes, because there has been a lot of technical debt, there hasn't been a lot of things waiting in the system test environment. So then, if Oda had an issue where I found a bug, we just fixed it and gotten it out together with the actual feature or issue that she was developing. So that is also one of the reasons why we haven't had so many bugs. But of course, we are good at what we do, and we've been there for a long time. So that is also, hopefully, one of the reasons why we don't have bugs, and not the fact that they don't use our product, because we know they do. And then, what are we doing today? Or how are we going to continue this fairy tale?
We are by no means finished. There's still a lot of things we want to take a look at. One of the things are a more loose coupling of our services, because we do have quite a few dependencies within our architecture. We even have some services that is a Java dependency that was never intended to be a Java dependency. They were supposed to communicate through service calls, but something happened. So we have to take a look at that. We also want more extensive end-to-end testing. We have, as Tina mentioned, some Selenium tests. They use the graphical user interface, but unfortunately they are a bit unstable and they take a very long time to run, so they are not part of our pipeline today. They are triggered whenever we put something into the system test environment and they run, but if a test fails here, that will not stop the deploy. So that is something we have to take a look at. We are also looking at replacing our old SOAP services using XML to start writing REST services in JSON. All new services are to be written as a REST service, but we also try to rewrite our older services as well. Some of the reason for this is because we have a older front end is written in plain JavaScript with a few libraries, but we want to modernize it a bit. We've been looking at trying to rewrite it to React, and then we also, it's a lot easier if we can use a REST service with JSON instead. But today we deploy by need, often daily, sometimes even twice a day, because we as a team deploy ourselves and we also have the responsibility to monitor the system's behavior. This has increased the sense of ownership to the system. Now, I as a developer, I'm part of making the acceptance criteria, the specifications. I implement them, I test using Trass, I deploy it, I monitor it, and we have daily meetings where everyone in the team is involved, so we can, everyone has get the latest status on how the system is working, on which features we are doing, and we also, if there's a problem, if we see that a requirement is not really what we want when we develop, it's easy to change it because the system owner is there, the tester is there, someone from operations is there. So we have all these counselors or help that we can use on a daily basis.
Yeah, and we have learned so much these last few years. We have read a lot, and we have tested a lot. We have failed a lot, of course. This hasn't been this joyous journey the whole time. There have been times where we have just, yeah, it's been hard. But, of course, we have learned so many new things. I actually had to step in as a developer because all of the developers were working on technical debt, and the system owners wanted us to get some new features out. And everyone has just stepped up to the plate and tried to figure out, okay, how can we do this? What's the best way of doing this? Sometimes we've had some coaches and so on. And the best thing about this is that we have done this together as a team. We are not that much of a supplier and customer. We are more a team that is working, actually, we are working more closely and more together than we have ever done before. Like Oda said, we have daily meetings, the whole team. And we have done this together, and it's just been such a fun ride. So now I'm guessing you're all wondering, did we actually live happily ever after?
We'll have to see, because the fairy tale is continuous.
Thank you so much.
I think we have time for a few questions if there are any. If not, you can find us at the supplier stand. Yeah. Or
Okay, feature toggles.
Mm-hmm.
How do you make sure you don't get thousands and thousands?
Yeah.
Good question. We
Well,
have had problems with those.
It's she was wondering how do we manage our feature toggles so we don't have hundreds of them. Of course, it's easy to forget a feature toggle when once it's turned on in production. It's been on for weeks, perhaps months. We actually a few weeks ago found a feature toggle that we forgot to remove from the code. So actually, we make another Jira issue that we put a date on to remember to remove it. But it's something that's, I hope it's going to be easier when we start using Unleash, because then we will have a dashboard where we actually see them, so it's not that easy to forget them. Yeah.
Yeah, technical tests. How do you enforce or who or what enforces the developers to actually write them? Because from experience, that's tricky.
Okay.
Yeah.
So the question is how to get developers to actually make tests.
Yeah, I'm sometimes when we are trussing, I'm just saying that, okay, have you created tests for these? And they're like, no. And then I say, okay, when you've done this, then you can push your issues into the system test environment. But of course, that's not all.
There's something about when you make a bug and you actually make something break in production, you don't really want to do that again. So once you've done it once or twice, you are going to make sure it works the next time. So you are going to make the tests. It's something that in the beginning we have had to try to enforce, but after a while it's come naturally. I think the culture has changed a bit. So now it's the testers, and they can tell you what they want to test, what they think is a potential bug, and then we make tests for it, because we don't really want to make any bugs and break production.
Yeah, and you don't want to stop the flow either. Like I said, if Oda has an issue in the system test environment, and then Ole comes, and then I found a bug on Oda's case, then it stops maybe both her and Ole's case. And that's not something anyone wants to be the reason for everything stopping, which is also why we are trusting, because then hopefully we will find the bugs. But of course it's been hard, but it's also something we have said, if we are to deliver more continuously, we have to have the technical tests in place. If not, we can't do this. Yeah.
How do testers get access to test on the branch?
Testing on the branch, it's only us that are from the suppliers who can test on the branch. But I've actually, since I've also been developing a bit, of course, I've just downloaded the code from Bitbucket, cloned all the repos, and then I just, take it on.
Yeah, we can give access to the caseworker testers as well, but until now they're not interested in trying to do on code, try to run the code themselves. But we do have some demos where I, as a developer, can I just run it locally and I show it to them, and we do it on my computer. It's a bit easier when we sit in the same location, but of course it's no problem using Teams or we use IntelliJ, so we use the Code with Me plugin. So then it's quite easy. They can just take over. But I will be the one actually running the code.
Yeah, and I have a computer science degree, so I am technical. I've just not worked so much technical. So, and that actually applies to all of the testers that we've had on our team. They are technical, so they can do this if they want. And if there are something we can't do, we just ask the developers for help.
Testers run it like the developers do.
Yeah, because it only works on their machine sometimes.
Yeah.
You mentioned some hard deadlines.
Yeah.
And some what you call knowledge experts testers. How do you incorporate those hard deadlines and the cooperation with those people in this new continuous delivery?
Okay, so how to integrate hard deadlines with this continuous fairytale? Usually we just have fixed deadlines when there's a law change, a new law that is to be enforced, and luckily we do get some heads up. So we develop it, we deploy it, and it lies in production, but we have turned it off using a feature toggle or feature flag. So that particular day we just turn it on, so we can then reach the fixed date. But of course, we do need some time in advance to actually develop it.
Yeah,
So we can't do it on a day.
Yeah, and the testers, of course, I'm there all the time. And the testers, the caseworkers that we have, they're also there all the time. They come for about 2 weeks each. And there are always 2 testers that are there at our disposal, so that we always have some testers that we can use if necessary.
It's a bit dark, but are there any more questions? Yeah.
And how has the frequency and the nature of production incidents changed with your move to continuous delivery?
So how often we deploy? No.
And how often do you have problems in production?
How often do we have problems in production? It hasn't increased. It's about the same as before. But now we have there's a mantra: if you break it, you fix it. So the feedback loop is a lot shorter. So we actually, if we break something, it happens when we deploy, and then we can actually just fix it instead of getting the bug a month or weeks later.
Yeah, and we're also lucky that our system, like I said, it's been in production since 2013. It's been stable and running the whole time. We haven't had many issues with it, so things have just been stable. So it's not often that we don't discover things before it actually goes into production.
It has happened.
Yeah.
We did have an incident where we deployed there was a new SQL query where we didn't realize there was a bug until 4 hours later, because then the threads to the database stopped it.
Yeah.
So the developer who had deployed to production, of course, looked at the Splunk logs and the Grafana dashboards. Everything was fine, but he didn't look for 4 hours because he thought it was fine. So the next day we had to roll back. But that's only one big
that's the
bug
only
that we have had.
big
the
issue.
others are
Yeah.
easy to fix, or we can live with them for a few days.
Yeah. Yeah.
Have you had any changes to logging or surveillance of the production environments, or have you noticed that you need more logging?
Okay, so if we need any more logging after we've started using this method, the Atlas platform helps us make Vegvesenet uses Splunk as their tool for creating readable logs, and so they are searchable. And the platform helps us making those indexes and create the root catalog for our logs. So we try to use it the same way as before, and that Atlas team has enabled that for us. So we as a developing team doesn't have to do much changes. But of course, we do see some areas where we want more logs that we didn't have before. So we have increased somewhere in some of the services. Often, if something breaks, the stack trace wasn't really that easy to read, so we wanted more information in the log. So we have changed it a bit, so that is easier for everyone, not just the one person who made that service to fix. I'm not sure if that answered your question.
Yeah.
Mm-hmm. Sorry, I didn't hear. Okay, so how to use feature toggles in database? I don't think we've tried that.
Yeah, because normally when is something we have to add to the database or such, and the rest of the things are feature toggled, it doesn't actually do anything. It just lies there and wait.
We still have the ability to, of course, if there is a database script that can't be run as part of deployment because we have a feature toggle, we still can use operations. We do have a daily meeting with them, or they're part of the daily meeting, and we still can get a resource from operations to run the database script on that particular day if we want to. But we haven't been in that situation yet. We probably will.
Yeah.
So now I can think about that until it happens. Yeah.
Follow-up question to that. Have you come across many issues with backward compatibility, or when you think about forward and backward compatibility?
Yeah, so problems about backward compatibility. We do have some integrations towards other systems where we have still SOAP services, and those contracts are can be quite strict. And that's we actually this week we're having a issue with this, and we haven't figured out how to do it smoothly yet, because we still if we make a breaking change in the contract, we need them to start using it at the same time as we deploy.
Yeah, or we also just it lays there until somebody picks it up and starts using it, because we also have something that we put into production. I think it was in September or October, that hasn't been used yet.
So we can make a copy of the contract and develop that further, and then they can start using it later. But it's not super smooth.
Yeah.
Are you using rollback scripts with the flyway if you're going?
We have tried it in test just to see if it works.
Yeah, the question was rollback scripts.
Sorry, using Flyway. We haven't tried it in production yet, but we might have to. We've tried it in test. It worked. We had to try it twice because we didn't really manage it the first time. So it's a bit exciting to see if we have to do it in production and if we actually manage it. But we try to not have to roll back. We try to always go forward. So instead of rolling back, we just try to push a new fix. But of course, that might not always be possible.
Yeah, it depends on how long the fix takes.
Are we done?
Thank you so much.
Thank you.